All right, welcome. Today we're going to go on a bit of a journey, uncovering the hidden connections between some of history's absolute greatest ideas. We're going to follow this single, fascinating thread that winds its way through centuries of science and philosophy, linking discoveries you would probably never, ever expect to be linked. The author Stephen King has this amazing way of thinking about creativity. He doesn't see stories as things you invent, but as things you find, like fossils just waiting in the ground. And the job of the writer is to carefully excavate them. Well, today we're grabbing our tools because we are about to dig up a truly remarkable intellectual fossil. So here's a question for you. What in the world connects a theory of gravity, the force that holds galaxies together, with the phone that's probably in your hand right now? I know, it sounds like a riddle, right? But the answer? Well, the answer reveals this incredible chain of intellectual inheritance, a story that spans centuries and connects some of the greatest minds in history. Okay, so our story kicks off in the early 20th century with a mind that would completely reshape how we see the universe. And it all starts with this one astonishing burst of pure genius. Back in 1905, a young Albert Einstein has what's now called his annus mirabilis, his miracle year. He publishes 4 papers that just change physics forever. But 10 years later, he drops his true masterpiece, the general theory of relativity. And this wasn't just an update, it was a total reimagining of what gravity even is. I mean, you really can't overstate how wild this idea was. Einstein basically said, hey, gravity isn't a force pulling things together. It's actually a curve in the fabric of space-time itself. And from that totally mind-bending idea came a very specific, testable prediction. The sun's massive gravity should actually bend the light from distant stars as it passes by. Okay, but here's the thing. This created a massive problem. How on earth do you test that? The sun is so blindingly bright that seeing the faint stars anywhere near it is completely impossible. So how could anyone prove Einstein's theory? It seemed like it would take some kind of perfect cosmic coincidence just to even get a shot. And that's where the next link in our chain comes in. The person who took on this seemingly impossible challenge was a British astronomer named Sir Arthur Eddington. And he had a very bold idea. Eddington, he was such a fascinating character. He was a Quaker, a pacifist, and that was just as important as his scientific brilliance. See, this was all happening during World War I, and because of his beliefs, he was one of the only British scientists willing to even entertain a radical new theory coming from a German physicist. He believed science had no borders, which made him the perfect person to champion Einstein's work. And this is where Eddington has this flash of genius. He realizes a total solar eclipse would be the perfect natural experiment. For just a few minutes, the moon would block the sun's light, and he could actually photograph the stars right next to its edge. So he organizes this expedition in 1919, and when they analyzed the photos, there it was. The stars' positions had shifted, light itself had bent by the exact amount Einstein had predicted. And this one experiment made Albert Einstein a global superstar, like overnight. But of course, a mind like Einstein's doesn't just appear out of nowhere, right? He and Eddington were standing on the shoulders of a giant, a figure who laid the foundations 2 centuries earlier, whose ideas had defined physics for generations. We're talking about Isaac Newton, of course. And that famous story, it's not really about an apple hitting him on the head. The real stroke of genius wasn't getting bonked on the head. It was the question he asked himself, why does the apple fall straight down? And his incredible insight was that the same force pulling that apple to the ground was the very same force keeping the moon in orbit around the Earth. It was universal. And this one single idea led to his laws of motion and universal gravitation, which basically painted a picture of the cosmos as this perfect, giant clockwork machine. Suddenly, everything from a falling apple to the orbit of Jupiter operated on fixed, predictable rules. For the first time, the universe seemed like something we could actually understand. So Newton gives us this beautiful, orderly universe. Amazing, right? Well, there was a catch. This powerful new vision of the cosmos created a terrifying philosophical problem. If everything is just a big, predictable machine, where do we fit in? And that was the crisis Newton's universe created. In his world, every single effect has a cause, and it's all determined by physical laws. So, what about us? Are our choices, our feelings, our morality, are we just cogs in this giant machine? Is free will just an illusion? And this is where philosophy enters our story in a huge way. The philosopher who really stepped up to tackle this problem head-on was Immanuel Kant. He was absolutely determined to rescue human freedom from this clockwork universe. He argued that the source of what is good isn't found out there in nature or handed down by a god, but that it comes from within us, from the goodwill of a free person acting out of a sense of duty based on reason. Now, Kant's deep dive into the power of pure reason, it actually connects us to another brilliant mind, a contemporary and actually a pretty fierce rival of Isaac Newton himself. Let me introduce you to Gottfried Wilhelm Leibniz. Now, you might know him for co-inventing calculus, but his philosophical goal was just as massive. He believed that all complex thoughts could be broken down into their simplest parts, creating what he called an alphabet of human thought. And that whole quest led him to something truly revolutionary. What he came up with was the binary system. I mean, the genius of it is just how simple it is. Leibniz showed that with just two symbols, a 0 and a 1, basically an off and an on, you could represent any piece of information you could possibly imagine. For him, it was just this beautiful, elegant piece of abstract logic. And here's the next big jump in our story. That abstract system of logic from the 17th century, it's not some dusty old idea. It is, literally, the fundamental language of everything digital. Every single computer, every smartphone, it's all humming along on Leibniz's binary code. Okay, so this brings us rocketing forward into the modern era, where the incredible power of computers, machines built entirely on Leibniz's logic, unlocked a completely new way of seeing the patterns of the universe. So in the 70s, there's this mathematician, Benoit Mandelbrot, and he starts using these early IBM computers to do something pretty wild. He was basically telling a machine to draw a picture of a complex equation, and the results were just breathtaking. They revealed these infinitely intricate shapes that he decided to call fractals. So what's the secret sauce behind these incredible, complex patterns? It's a concept called recursion. It's just the process of repeating a simple rule over and over and over again in a self-similar way. You see it everywhere in nature. Think of a coastline, a snowflake, a fern. A really simple process, when it's repeated, can create absolutely boundless complexity. So think about this for a second. Our whole journey started with Newton's universe as this great, predictable machine. But with the help of computers, which were built on Leibniz's logic, we found these recursive fractal patterns everywhere. And as the physicist James Jeans put it, this totally changes our perspective. Suddenly, the universe doesn't seem like a big machine anymore. It starts to feel more like a great thought. So let's just trace that path one more time. Einstein's gravity, proven by Eddington, which replaced Newton's clockwork universe, which raised these huge questions for Kant, whose faith in reason connects him to Leibniz, whose binary logic built the computers that Mandelbrot used to find recursive patterns in the cosmos. It's all one story. Ideas are connected in these amazing, unexpected ways, just like fossils in the ground. And it really makes you wonder, doesn't it? What other hidden connections are out there, just waiting for us to find them?